We are now going to look at our third example of factoring trig expressions. First we have the example is sine to the fourth theta minus cosine to the fourth of theta. So we have a difference of powers of 4, not a difference of squares. We are going to follow the same steps we looked at before. I don't have them written out. By this point you should be comfortable with what they are. I will label though the first step by S1, which is to replace the trig functions with variables. So I'm going to call sine A and cosine B. If you haven't seen examples 1 and 3, please do that first before you do this example. So now the sine of theta gets replaced with A, so it becomes A to the fourth. Same for the cosine. It becomes B to the fourth. Now we have A to the fourth minus B to the fourth. This can be factored using the difference of squares. It's just it won't be our final step. Since these are even powers, we can factor this down using the difference of squares to a squared minus b squared, a squared plus b squared. These powers come simply by taking the, basically cutting this in the 4 in half. So if it was like a to the 6 minus b to the 6, it would be a cubed minus b cubed, a cubed plus b cubed, since that's half of 6. So now we have a squared minus b squared, a squared plus b squared. Now, as I said before, we need to completely factor this. Just because you factor it with one step doesn't mean you're done. Notice that what we have on the left is also a difference of squares. So we can factor this a squared minus b squared again down to a plus b, a minus b. The a squared plus b squared can't factor. There's no such thing as a sum of squares. So our final factored form of sine to the fourth theta minus cosine to the fourth of theta is sine theta plus cosine theta minus cosine theta, sine squared theta plus cosine squared of theta. Notice that all you do for the last step is you then just replace their the variables with what their corresponding trig functions are that you designated them to be. Now I will say there is one more step here. There is one more step that you can do, but we haven't learned Pythagorean identities yet, so I'm not going to go into a whole lot of detail. But if this asked you to simplify, once you learn Pythagorean identities, you will see that sine squared plus cosine squared is equal to 1. Okay? And I did want to go over this just because, it's important that you know that sometimes you will have to simplify these. So you'll be left with sine squared plus cosine, sine plus cosine, sine minus cosine. Let me just go ahead and lasso this over to the right. Okay, and that's times 1. And again, you'll learn that sine squared plus cosine squared is equal to 1. Now, if you have something times 1, it just equals itself, right? So if the direction said factor and simplify, then your final answer would be sine of theta plus cosine of theta times sine of theta minus cosine theta. Okay, however, the directions didn't technically say to factor and simplify, so you could just leave it as is for now. Again, that's because you don't know this Pythagorean identity. But this will be a good segue to know that in the future, if you do use Pythagorean identity, you could simplify this even more down to just this. That's it for this particular example of factoring trig expressions. If you have any other questions about it, let me know.